Great. Well, thank you for the introduction and for the inviting me here to speak with you guys. Really appreciate the opportunity and excited to do so. Um, yeah, on top of what was mentioned, I also worked at Google X, and as part of what I'm going to talk to you guys a little bit about what that experience was like and what moonshot thinking is about at Google and just in general, I think at large. So, two topics that I'm going to cover over the next 15 minutes. I want to talk about how Google wanted to disrupt itself and what moonshot thinking is. And then I'm going to talk a little bit about self-driving cars and the exciting part about working on this particular moonshot to not only develop that technology, but also the disruptive technologies that are entering the market today. I look forward to your questions. Please add them to the Q&A section, and I will address them at the end of this briefing or at the panel discussion later on today. So with that, I'm going to start with what Google X is and what moonshot thinking is. So at a high level, X is an incubator for moonshot ideas. And it started by the founders, Larry and Sergey, wanted to disrupt themselves before they would be disrupted by industry. And that's where that thought came in and inside of Google, and they created this division called Google X. And X is best known for the self-driving car team called Waymo. It consists of, like, what moonshot thinking consists of is that you have these three circles. One is a huge problem, then a radical solution, and then a breakthrough technology. So let me give you a high-level example. So you may have a huge problem of transportation. Like, let's say I want to go from here to there. I want to move goods from here to Georgia, for example. What if we could do a radical solution of teleportation, right? Instead of getting into a car, an airplane, or a train, or etc., just teleport there. That would be a radical solution to solve this problem, but it wouldn't meet that third circle of a breakthrough technology. Right now, we'd have to create wormholes, and our understanding of that technology is still scratching the surface. So this is kind of where X was born, and they've had some great successes in cybersecurity companies, self-driving cars, and fully autonomous drones for delivery. They're also known for notable failures, right? Google Glass being a classic example, along with a smart contact lens. So let me talk a little bit about what the process is in terms of how you move through this innovation. It starts, first of all, you got to think of X as an incubator for moonshots. And I'm going to touch on that in a little bit. The idea comes from, at the first phase, ideas can come from anywhere inside of Google for evaluation. But again, it has to meet this intersection of a huge problem, a radical solution, and a breakthrough technology that's able to address it. Another thing that is kind of not openly discussed, but a high factor as well is a profitability. This is a for-profit business, so there has to be a path to reach revenue. So and they mentioned frequently it's got to have like a 10 billion path in 10 years. And then Larry Page also asks, like, hey, does it pass the toothbrush test? And what he means by that is we brush our teeth twice a day. Is this a technology? Is this something that I'm going to be using twice a day at least? So that's kind of some of the thought process there. Should you pass the litmus test, you then go to the rapid eval team to really assess the technology. I like to think of them as the myth busters, right? X has its own labs and test sites to conduct small and large experiments. And really what the Mythbuster team, Rapid Eval team, is trying to do is identify whether this technology is really achievable. And is there a really huge problem to address? And in fact, a high degree of failure is expected and encouraged at this phase because it's a lot cheaper to fail now than it is if the project moves forward, right? It's a lot easier to kill a project when there's been very little capital or effort put into it rather than moving it forward, forcing something to move forward and then killing it as it becomes more expensive. And in fact, X embraces failure with what they call Dia de los Muertos, or in conjunction with Dia de los Muertos, where they revisit projects that have died. Because there may be a technology that 5 years ago, or an idea that came out 5 years ago and wasn't valid then, but now is because of some breakthrough. After they go to passing rapid eval. Everything, by the way, still in stealth mode. Nothing is being announced. X brings in the world leaders of that particular concept. In some cases, they bring professors who've done thesis work or do research work in this field, and they'll bring them in, attract that talent to explore and advance this breakthrough technology. And really, the idea at this point is, can we evaluate it in the real world and see what's going out, taking the experiment out of the lab? Another goal, this proof of concept, is to understand the current limitations of technology, regulatory hurdles. Are there ethical hurdles around doing something like this? And at this point, X still kills a lot of the projects. But in this case, once you build a proof of concept, in some cases, the lead, and I've got a few examples here, but I'll bring up one, a company called Dandelion, that's a geothermal energy harvesting company with the CEO, Kathy Hunan, who was leading this effort. X felt like this effort wasn't, it didn't encompass the vision of X, so she spun off that technology, got approval to use it, and is doing her own company now to bring this to the market. Anyways, after that, you go to building a product phase. And this is where X announces that it's got this new moonshot and brings a team to execute on the effort. They focus on products such as Google Glass, Waymo, Wing, Makani, the smart contacts lens. And even at this phase, before you graduate, you still have failures and and breakout successes. And as I mentioned, after that, you graduate. So X, again, is an incubator facility. They focus on developing these moonshots, but then they launch their own companies, right? These technologies may not be in line with Google at large. It may not fit with the vision of Google. So as such, they go off and create their own company, their own culture. And you can see these cultures being born inside of X. And that's really the intention of this. And they've had, again, great success with Waymo, Wing, and Chronicle, a cybersecurity company. So let me go into a quick example of this process in application. So they identified this huge problem of last mile delivery. And they were looking at drones to be a breakthrough technology that could help deal with congestion and environmental impact. For example, today, my pharmacy is about 6 kilometers away, but it takes me 20 minutes to drive there. I have to wait 10 minutes for my prescription to be filled or provided to me at the register, then another 20 minutes to come back home. And after that, so it's like, is there a better way to do this rather than spending all this time and effort? And this is kind of where this idea came through. It's like, hey, we have the sky, we can go up, and there's a technology that can get us there. So that being said, they then developed the prototype, right? They brought in professors from MIT and his team to build a prototype, and they wanted to identify how bounding conditions. For example, how big could this drone be? Do I want it the size of a car? Do I want it the size of a table? How much weight could it carry? Where could it operate? Can it operate at day? Can it operate at night? Can it operate on open fields or with power lines? How far could it go? All these things they were trying to understand to see if, like, okay, now that we know what is reasonable here, can we go and take this technology elsewhere? From there, we went to the pilot program and launched the technology. So what we did first, once we proved out the feasibility, is we had to get this thing flying fully autonomously, right? The idea is you just load the package and you program where it needs to go, and it'll just fly there by itself. And then also delivering and developing a strategy for securing your beachhead. So this is where we secured our partners with FedEx and also areas where we could do deliveries. So we are in operation over in Australia, the United Kingdom, and in some towns here in the United States. And Wing has also grown significantly over the last few months as a result of the pandemic. Wing has been able to quickly, cheaply deliver food and medicine to customers without human interaction. So that's an application of how this moonshot process works. So let me jump a little bit to a slightly different approach to innovation. and talk about self-driving cars and what the market is doing in developing disruptive technologies that come out of pursuing this vision, this dream. So I'll start with first, like when I first came to Silicon Valley, this was about 5 years ago now, I saw Google's self-driving car for the first time, and I was truly amazed to see what was happening here in Silicon Valley. It's also great to see friends and relatives come down to town for the first time, and invite you guys also to come out here and see your first self-driving car. It's pretty exciting to see all this stuff happen around you and operating, and really it inspires you to see that this area is truly innovative. And in this case, where this was born from was DARPA had a grand challenge in 2005 where a Stanford team won and successfully demonstrated full autonomous driving in an urban environment. And at the time, this was again 15 years ago, it seemed like the problem was solved. But I can get into that in a separate discussion. And since then, Google has become a leading developer in full autonomous vehicles. But there are other cars and companies that are not far behind, or excuse me, have slightly different business models, such as Cruise, Tesla, Neuro, Argo AI, self-driving trucks, lots of different ideas on how to bring this technology to the market and applications. But when we talk about self-driving, there's really two fundamental types. There's two different classes. There's the human-centered. In other words, a human is fundamentally responsible for driving, and autonomy is designed to assist you in driving. This is very practical and is able to get into the market today. In fact, you see it in Tesla and Cadillac, Super Cruise. And then finally, you have full autonomy, which means at the end of the day, you have artificial intelligence fundamentally responsible for the operation of the vehicle. In other words, you can imagine there's no steering wheel, no way to drive this thing. There's no gas or brake pedal. You just get in and it goes to its destination and you get out. That's the big differentiator there. So, and when it comes to full autonomy, full self-driving cars, you have a complex system of sensors. You have dozens of different types of sensors, computational power. These things have literally supercomputers inside of them to operate. You have advanced algorithms in machine learning, perception, and heavy operations. It takes a lot of people to get these things on the road and operating consistently and digesting all this data and analyzing it to improve on it. And we could spend hours on each one of these systems. But for this brief, what I'm going to focus on a little bit is technologies that have entered the market today as a result of pursuing full autonomy. I'll start with NVIDIA, because this is a great story. Elon Musk approached NVIDIA. They wanted a new processor for their autopilot system. And the CEO, he gives a great talk on this, but they developed this V100 chip, which was a high-performance graphics processor used for self-driving. And they spent billions of dollars, teams of thousands of people in about 3 years to develop this technology. And as a result, NVIDIA today is one of the leaders in terms of artificial intelligence processor capabilities that's used not just in self-driving cars, but you see it prevalent in any heavy neural network type system. Mobileye is a company that has sensors and processing combination that has one of the most advanced self-driving or driver assistance capabilities, and is pushing the envelopes and being able to have a car fully drive itself. And in fact, Mobileye in 2017 was acquired by Intel for $15.3 billion, one of the largest acquisitions in Israeli tech company. And then finally, LiDAR. LiDAR space has been growing exponentially with self-driving car giants acquiring companies. LiDAR is a technology that develops high-fidelity maps, shooting millions of laser pulses per second to get information. But unlike cameras, LiDAR systems do not rely on the light around it. It shoots its own light. It provides, so it can operate at night in inclement conditions, and with much higher precision than a radar system. Now, with that, you can see that Apple has really adopted this. The new iPhone 12 provides you, has a LiDAR system. And why they put it in there is because it has 6 times faster autofocus, operating at night with much better wide camera capabilities, and it has augmented reality. That's the most exciting thing that it has on it at the speed of light. I don't know if you've tried some of these augmented reality systems in the past where they're glitchy, they don't quite work, but you can imagine now you can play a game like Lemmings on your desk and on your couch, on your bed, where you see the lemmings walking across, or put on a new sneaker and then try it on virtually before you buy it and to see if it will fit. So huge opportunities that are happening as a result of this. And to wrap up, because I'm out of time, I could go on and on. It was great to speak with you guys today. And before we open it up to any questions, a little bit about my company. We are a deep tech company developing disruptive silicon process for sensors. With that, I look forward to continuing our discussion at the panel discussion later today. Thank you.